welcome to Scaling AI and the Enterprise Requirements of Agentic AI. And we have assembled an incredible panel here. So immediately starting to my left, our head of CX engineering globally, Mr. Bhaskar Jayasrikrishnan. He is the godfather of Cisco IQ. This man helped bring to life with an incredible team. So Bhaskar, thank you for being here. I want to welcome Dr. Lydia Chilton from Columbia University. Dr. Chilton is an associate professor of computer science, and her work really focuses on human-centered AI and how we bring humans in the loop and how we don't replace human intelligence, but we really augment it through agentic capabilities. She's going to have some great perspectives for us. Sam Charrington, the host of the TWIML podcast, a sought-after industry luminary, I think is a safe way to put it, brings incredible insight to this conversation. And then finally, Cisco's own Srini Nyamaneni. I always butcher your last name, I'm so sorry. He's our Nyamaneni, our Chief Automation and Information Officer. 30 years of experience in developing platforms and leading in the industry, and he's got some incredible insights for us as well today. But if you don't mind, let's start off. Start off with the paradox. I believe there was recently a study of 718 global IT leaders. 95% said that they were going to launch agentic AI projects in the coming year. But then upon first analysis, we find like 69% of them are completely unprepared. So I want to come to you. Not that they weren't prepared, but their organizations are not prepared. Their infrastructure is not prepared. Their processes and tooling is not prepared. So Bhaskar, what's going on here? Is that 95% number just bravado?
I think it's definitely bravado.
Okay.
Right.
There's some bravado in that statement, you know?
We are definitely seeing a lot of AI tourism. People are doing pilots, but then they are unable to take it to production for very many reasons. But the general trend that you observe is a lot of people obsess over a model's performance, how well a model does, right? But there is a core engineering challenge that needs to be addressed. For the last 3 decades, any piece of software, irrespective of the language that we use to develop it, there was one thing that you could be certain, right? It was the determinism. For a given input, it behaves exactly the same way. But with AI agents, you deal with a new core engineering challenge, probabilism, a probabilistic nature of AI agents, right? So if you take AI agents, you give it the data, you give it tools, but then it can get to an outcome using 3 different paths, right? So that's very different from what we are used to. Now, that behavior of being able to creatively come up with paths, that's the intelligence that we want, but it's a nightmare for reliability. So that takes us to the next element in terms of how do you build in guardrails. If you don't have the right guardrails, we are just accumulating liability.
Sam, I want to come to you on that one. So what's your immediate reaction to what Bhaskar said? Agree or?
I couldn't agree more. And in fact, I'd amplify the impact of non-determinism. We have been building these deterministic systems for a long time, and we know how to do them. We have a process. We've compressed the process from waterfall to agile, but it's still a process of we build and we test. And the testing is what gives us comfort, what allows us to trust these systems. But now we're introducing a new regime where testing is still necessary, but it's no longer sufficient. That's because these agents are highly probabilistic. They're making decisions probabilistically. They're even writing code that never existed before, that's new to production. You can't test for that. And so it's really a new paradigm for enterprises and an area that enterprises really struggle. And I think the thing that is most challenging is that the first instinct is, well, I'll make my prompt stronger. I'll make my prompt longer. But you can't prompt around these issues. You can't say, don't make any mistakes. You can't say, do it right. If you do, a cat will be harmed. I'll be fired. It doesn't work. We tried it. And so that really calls to question, how do we protect and guarantee trust? And that is really where guardrails come into place. And it raises a lot of really interesting questions about, how do we arise at these rules? Do we need AI to watch over the AI? There's a lot of interesting questions there.
Can I answer that?
No, please, yeah. But no felines were harmed in the making of this podcast. I think that's important.
Thank you for that disclosure.
So who's going to watch the AI? I think we need some people to watch over that AI. I get that AI is the shiny new toy, and I love it as much as the next person. But often the conversation about AI, we sort of don't really talk about the people as much because we're the old news. But we are still just as important. When you talk about this probabilistic nature of AI, absolutely, that's why you shouldn't let it loose. It's like letting a toddler, a very, very oddly capable toddler into your company. Like you would want to give it, yes, guardrails, some things that it can and cannot do, but also watch it, teach it to do some things. We should not just expect it to go out there and fix everything magically, although I know that's how marketing cycles sometimes teach it.
But don't we risk, and Bhaskar, I want to come back to you, but if we give it too many guardrails, doesn't it just become automation? We want the creativity, right?
You're absolutely right. I want to make a quick point on the probabilistic nature of it and come back, right? I think Sam was talking about how code has become, how the development cycles have become probabilistic, how we are testing it. But if you think of LLM as a judge, right, even testing has become probabilistic.
Right.
So we are layering probabilities on top of probabilities. So now coming back to your question in terms of if we make it too tight, yes, it's pretty much a script at that point. But then if you make it too loose, then you're arming a toddler with weapons with unforeseeable consequences. So with that said, one needs to think of the right balance. That's why you need some sort of a layered autonomy approach, where when the stakes are low, the agents can essentially make decisions on their own, right? When the stakes are high, the outcomes really, really matter, then you need much, much more guardrails built in so that there is a level of predictability.
The visual I have right now is a 4-year-old in a Batman costume, that level of confidence and power.
Right. So what you need to do is give that toddler some training wheels, observe them, and when you believe that they can perform the particular sequence of steps, then the training wheels come off.
Gotcha. Srini, I'd love to hear your thoughts, Sarah.
Yeah, the AI is fundamentally a different technology, right? When I say AI, Gen AI, like probabilism is something that most people know but really don't appreciate it, right? If you ask the same question multiple times, what is the color of the sky, right? 9 out of 10 times you will see blue. But other times you'll get actually different answers. It may not be the wrong answer. It's like light blue, still okay. Gray, maybe when it is cloudy. It just, in the probability there is a 0.001% or something that completely wrong answer can come. And the challenge is if you completely automate it, who is going to catch that, right? So that is where we have to be very careful on how we use this technology. So we are looking at AI across different operations like finance, legal, HR, you name it. Like across the company, we're using it, but we are meeting sometimes and someone comes and says, oh, I want to build a better finance forecast application using Gen AI. I'm like, what is that the regular ML or the statistic model that would not give it to you? And sometimes people just want to say, oh, I'm using AI, I'm there, but it will end up in the wrong answer. And then Eric would have to, as a sales leader, would have to sell a lot more with that forecast. So what we do is we really look at that question. Is this the right thing, right? So you're all, used to AI assistants now. Like you go FAQ, you give it, it's a natural language translation. They make mistakes, but we read it like, okay, I need to call someone because this is not right. So that's the lowest level. Like, okay, you can do human, Lydia says, like, human is in the loop. We are the human. We're looking at the answer and like, okay, this doesn't make any sense. But that doesn't mean we can't use it for a higher level. There are some operations where you can actually use it without really, worrying about the consequences. Let me give an example in our commerce operations. We get about 1 million cases every year. And there is like a support agent. They look at them, they have email exchanges going back and forth. It could take weeks for these cases to close. At the end of the case, we kind of look at like, okay, satisfaction of the customer, or even the agent, whether they followed all the instructions or not, we do an audit check. Because the audit is so intensive on a million cases, we do about 5% of the cases that get audited. And instead of saying like, okay, let's make those agents more efficient, give them AI tools, we thought differently. Let's just automate the entire thing. Every single case from the first interaction goes through AI screening. All AI does is sentiment analysis. Okay, what is the customer feeling about the interaction so far? And at some point, if it sees all caps or in a bad language, it doesn't wait till the case is closed. It actually escalates to a manager. A human in the loop will call them, hey, this is the interact, right? So I want to step back and say, like, now, does it make mistakes? Yes. What kind of mistakes can it make? 2 types, right? So let's say there is a customer that was not angry, and it made a mistake and said, customer is angry. So I'm going to just use Lydia as the manager because Lydia will look at it and say, this is not really use case. This customer, and she won't even pick up the phone. Like she says, okay, this is not there, right? But on the other hand, when a customer is actually angry, it missed it because this is the other type of the case. Yes, we complete that case never gets seen. But if you think about how maybe 2% of the cases are like that. At one time, we were only able to test 5%. Now we're doing 98%. Yeah, so see, that's how you can find value using the technology. Even though this is a probabilistic technology, even though this is not perfect, there are use cases like that. And I do agree with Lydia that humans in the loop still have to be there until we figure out that perfect autonomy. Because that people say, like, I'm using multiple agents in sequence. If you have more than one agent, first agent makes 90% correct. So the next agent makes 90% correct. Together, they make 81% correct. 0.9 times 0.9. If you put 10 agents in a sequence, you are guaranteed. You're guaranteed. Because it will be less than 50%, right? So these are the things to think about. There is other ways. I think you said LLM as Jed. We'll come back to it. There are ways to mitigate it, but this is what we're working with, and there is a lot of uses. Tiered, I like that word.
Layered
autonomy, or you call it tiered autonomy. Very nice.
That just sounds like a very, very, very big token bill, and we've talked about this. But so what's the answer? I mean, how do we not limit it and turn it into just basic scripting, but how do we make sure that again we don't have I guess chaos as well? What's the answer, Bhaskar?
So as we developed these agents and as we went through our own learning process, the one thing that we learned is auditability is key. Mm-hmm. Every action taken by the AI agent needs to be auditable so that you can explain why it did what it did. And if an AI agent goes rogue, then you will read about it in the press. You've seen some stories about people go to an AI assistant and asking it to write a piece of Python code, and it does. Mm-hmm. Because that AI assistant doesn't have the right guardrails to say that I shouldn't be answering questions about this. People have bought flight tickets for $1. People have taken over somebody else's account by asking nicely. So you need those guardrails, and those need to be architected in. It's not an afterthought. So the way we think of it is if you want to avoid bad PR, you need fast PR. Fast PR.
I was like good PR, but okay, fast PR.
Fast PR is the name of the framework that we use for responsible AI. As you develop agents, you have to bake in fairness, accountability, security, transparency, privacy, reliability. All of these are non-negotiable. And if you don't build it in, you are just building liability.
And it's an all or nothing.
Yep. You need all of this.
I like that. That's comprehensive. Sam, again, is this something that's resonating in the industry? Is this what you're hearing from other players other than Cisco?
Well, absolutely. As an analyst, I love a framework. Any framework is great. But when I hear that, what resonates most strongly with me is this idea of reliability. And it's not because I think we need to or we can make these agents reliable. It's that where folks struggle is that agents challenge our fundamental notions of reliability and control. We kind of alluded to this earlier. And I think the through line from all of fast PR is really trust. And when you hear about promising AI applications that have great proofs of concept and people are excited about them, but they fail to get into production, they fail to reach scale. That's usually a failing of trust. Someone couldn't get comfortable with this probabilistic nature, this non-determinism. And so I think thinking about that framework is really thinking about what it means from a mindset shift perspective. That said, Bhaskar and I were chatting yesterday about accountability, and you gave this great example of when organizations are pushing their engineers to develop applications using AI, and AI is generating lots and lots of the code that's now being pushed through the engineering process. It really challenges these notions of accountability. And we were talking about Batman. I thought about Spider-Man with great responsibility, or with great power comes great responsibility. The question is, where does that responsibility lie? Who's accountable for that? So also a really interesting element of that framework.
Actually, Sam, I want to amplify your message. When it comes to accountability, right, I think it's non-negotiable. The humans, at the end of the day, they are accountable, right? So when we deliver a bad piece of code, the buck stops with me. I mean, I need to answer for any results, any outcomes as a result of it. I can't just point to it and say, oh, wait, an AI agent developed it. So given that the accountability stops with the human beings in any arena, we also have the responsibility to make sure that it is built in with that auditability from day one.
I love that. But think of that person who's taking accountability. They need to know things from the AI to decide, is this a good thing that it did or a bad thing that it did? So being able to observe, to inquire, to see its evidence of what it did is absolutely important. The same that I would want from a junior employee or a senior employee. So this black box nature of AI, yeah, there's some amount of that, and like we don't know exactly how it predicts this, but in terms of like the reasons it does things, the steps it takes, what data it queried to get it, a lot of those things are knowable and inspectable. And I was like, yes, that's a reasonable thing to do.
So that actually, Lydia makes a good point, and that reminds me of a conversation Lydia and I had yesterday in terms of for each of us to be a law-abiding citizen, we should have read the Constitution, we should have read the federal laws, we should have read the local laws if you actually want to be, right? But all of us have a sense of right, wrong, and we figure it out, right? But with an AI agent, you have to codify it. You need to specify every little part. So that brings in that element in terms of how do you account for it? How much of instructions do you give?
Right.
Yeah, where I hear a lot of this conversation going is that in order to have accountability and responsibility, we need a process that supports that. And I'm not talking about a workflow, a technical process. I'm talking about a human process that supports these things.
I mean, what I think is funny about this conversation, and I don't know why right now I'm picturing Howell 9000 saying, I'm afraid I can't do that, Dave. So we need to, let's reset this for just a second. So, I mean, what we're really talking about, I mean, again, remove AI, really we're talking about an enterprise phenomenon that is not new, which is drift, right? How is what we've intended the solution to do versus the solution showing up as, or if we can talk about this in a network term, the network configuration was supposed to be this, but now it's all of a sudden there's VLANs and firewall rules and things that no one understands how it got there, but yet there it is. So, I mean, Srini, I want to come back to you because you got to do this at scale in a very, very large, very demanding organization. I would love your thoughts here.
Yeah, no, I mean, if you're doing machine language, ML type of things, the models get drift. The fundamental assumptions change on which you trained, and then now you have to do that. You just have to redo those things. But in the Gen AI world, it is harder because the drift is real. You start with certain set of assumptions, and you do it, and then over the time, these unsaid things, you have to be documenting them and go back. But reality, what we do is we just use another LLM as a judge, right? So you kind of see what is the expectation, what is happening, and we do a lot of analysis with users giving thumbs up or thumbs down, and then many of the times what happens is they just don't even respond. They may be happy with an answer, or they may be just like, this is too bad, I'm not even going to bother giving feedback. So we actually go back to those answers as well, and then see like, okay, where the users have not done something, what was the right answer, what was the wrong answer, and we have to do it at scale. And this is just basically validating, and because we got to be on, this mindset, like these things are not perfect, these things are maturing technology. There is a lot of power, but you can't just be happy that, it gave me answer 99%. That 1% could be really bad answer, and we got to keep constantly on the whistle.
So the question becomes, and Lydia, I know you're going to squirm when I ask this question, but I mean, can we give the models autonomy, or do I need maybe a model watching those two models? and I think like yesterday we were talking about this, and it sounds like we need a compass, a GPS, and a map in order to again keep the systems working the way we want to. I don't know, Bhaskar, are we ready for it? Are we ready for autonomy?
Genie's out of the bottle. You can't put it back.
So I'm probably the most contrarian person here,
Okay,
but
let's
I
hear it.
actually do believe that there are places where we can give AI autonomy, but not right away. Mm-hmm. We have to let it earn our trust.
Okay.
And we have to think about, well, what's the worst that could happen, and could I recover from that? So for example, when I'm making code changes and an AI says, hey, I'd like to reorganize your entire code base and it'll give you this great benefit, I could say yes, because I know I can revert later.
Oh, okay.
So that, and I can see what it does, I can test what it does. I have a whole human process in place, and a lot of that is testing. Just good old-fashioned testing to see if what it promised me is what it's going to want to deliver. And that's why agentic coding has become like a big thing, because very little of it actually like directly impacts customers. But if you're talking to a customer and you promise them, oh yes, you can have the next year of service for free, that you can't take that back. There's like, I haven't read the Constitution, but I think there's a law about that. So you do have to think about the trade-offs in these in the problems that you're solving, and maybe start with the ones where you don't have these risks of over-promising. Make sure you're not going into any, I guess you call it like a one-way door, like that you can't take it back. But there are many problems with that signature and hallmark, so not all problems are created equal. You have to choose the ones that are going to limit your the blast radius.
I just had an agentic customer service experience, and I like to think of it as high risk, but they probably didn't. I ordered a pizza on an app, and it literally was just like, "Hi, I'm your AI assistant. Tell me what you want." Told it what I wanted. Didn't even ask for the delivery address. Pizza was there. So that to me was very high risk, because I was very hungry at the time. But for Papa John's, it was a low risk thing. But again, like what we're really talking about is like choosing. It's almost a workload argument, right? Where certain workloads, no regrets move, and if something gets messed up or we need to go back and fix. But other ones where, again, talking about high-end customer service, you're talking about terms and services, you're talking about really crown jewels of a company. The rules do change back to your human in the loop.
Unless it gets your accent wrong. And when you say 14, it thinks of it as 40, and you have 40 pizzas in your house.
That's a big pizza. That's a lot of pizza.
Sorry, Sam. Lydia's coding example illustrates something really nicely, and that is what gave you comfort that you can tell the agent to go ahead and change your code base is that you had that code committed to a repo, or you had a backup. That's a guardrail. That's not necessarily an agentic guardrail, but it's a real-world guardrail, and that's what gave you trust.
So, Lydia, you used a term earlier, black box. Like that essentially AI is this black box we're not supposed to understand, we can't understand. Bhaskar, did you just build a big black box with IQ? Is that what we're dealing with? Is that what we're putting out in front of our customers?
As we build these pieces of software, right? As I said, auditability is part of that foundation. You build it in. And even as we do this, we just don't point a model to a set of data and say, all right, go solve an asset reconciliation problem. You kind of build it up step by step, right? So for us, it's not a black box. It's specific tasks, specific guardrails, specific outcomes, and that's essentially how you build it. And as part of this, right, the one thing that we typically overlook is the importance of data. Data is critical. You have to bring together data, and that itself is a huge effort. Now, if we don't take all of this into consideration, we can declare victory that we developed this amazing AI agent, but you really built a random output generator because you can't rely on it. So with those guardrails, of course, you can get a lot done.
Okay.
When I think about what you're saying, what the analogy that really lands for me is thinking about like ChatGPT when it was first released. What did we use it for? Generating funny jokes, reading poems in pirate, right? What's the difference between that and the technology we have? Yeah, now the models are better, sure, but it's context. We have ways that we can inject our context into what the model is doing. In an enterprise perspective, or from an enterprise perspective, that context is data. That's where the value is created.
Okay, I want to just add something to that. So yes, the data is absolutely foundational. If you don't have the data, like how could anyone, human or machine, make a judgment about anything? But with every system that I have seen with AI, there's some amount of data that's important that still only lives in people's heads. And so, yeah, even though I know how the code runs, I also know things about the business processes that aren't embedded in the code. So like, oh, if we screw this up, if this goes wrong, we're going to lose a lot of money. So maybe let's not take that risk. And those are things that are difficult to codify. People have learned over the time. I suppose we could write them down if we tried really hard.
We just do that thing, we put the chip in someone's head, and they can just like, just get to the source, it's another data source.
Yeah, and then they could remove my entire brain while they're at it. Yes, I think I've seen that episode of Black Mirror.
That's really throwing me back to a prior life when I was focused on knowledge management, and we used to talk about tacit and explicit knowledge. It's been a problem for a very long time, and it will continue to be a problem.
Exactly. So old problems keep coming back, and this is why we need testing, people, processes. There's a lot to be excited about, but you don't just throw out everything from the past.
If there was an easy way to get tribal knowledge codified, we would all.
I think one thing that we're not acknowledging is even the explicit knowledge sits in multiple data warehouses.
True.
Sits in apps. Sits not even in the warehouses. It's like without that, right? So and then even if the data is available, it is not labeled properly. Like if I want to ask them what are the bookings for the last quarter for the product line X, it seems like a simple question. Then acquisition data is in a different place in the app, and bookings definition is different. And it's like that itself has to be solved. I mean, you're right. We need that also, but we are trying to even get the basic stuff done.
Yeah, so we're almost at time. I just want to come to a quick round robin, but I do want to ask Srini just 1 minute. If you think about everything we just talked about again, like let's talk about the coding specifically. Are we risking engineers as we currently define them? People develop software, develop these capabilities. Do we potentially risk them losing that craft, or again, knowing even if the AI generated code is correct or not, because they don't know how to build it in the first place?
Yeah, no, okay, back in college, more than 3 decades ago, right? I programmed in assembly language, then in C, then C++, then Java, Perl, Python. I mean, you go the progression. There is a difference in the determinism, how the code gets written, but I think this is the next level. It's like where I say the intent, right? So when I got the C language, I didn't miss the assembly language. When I got to Java, I didn't miss the memory management. I mean, there is always a better thing. The spec-driven development is that kind of evolution. If I'm an engineer, I would feel bad, like, oh, all the stuff I learned is not that useful anymore. Someone with an English major would be just as good, except that I do know the architecture. I do know what our operating system works. The framework helps me. So I think I still have an advantage. And we do see a lot of interest in our engineers to adopt, right? Because they see that if they don't do that, someone else will do that job. So there is this is not my word, but I heard it, I really like it, so I'm going to use this: artisanal coders. There will be few where they have to handcraft, but the rest of the mass type of coding will be done with
I love it. I love it. All right, team, we're almost at time, so I want to do a quick round robin. IT leader listening to this podcast, and we've had so much good dialogue and back and forth, but just this is your moment to be unchallenged. What's the one thing you would want an IT leader that's listening to this podcast to take away? And we're just going to go down the line. We're going to start with my good friend, Oscar.
Data fabric and governance. Data fabric, Srini alluded to it, data is fragmented. If you don't bring all the data together and if you don't give the right context, you're not making the best of what AI agents has to offer. The next, with respect to governance, if you don't have the FastPR framework built in, you're building liability, not intelligence.
We do not need any more liability. Lydia, please.
You really have to continue to consider where humans sit in AI. Like, yes, we're not just going from 0 to 60. There's going to be stages along the way of these tiers. And here's my message. Let AI earn your people's trust. Find ways and processes that they can see it incrementally and decide, yes, this is going in the right direction, or no, I need more guardrails, and build it up.
Love it. Sam?
For me, it's really about coming to terms with this fundamental shift, and that is to non-deterministic systems. And the only way to do that is to roll up your sleeves and get some hands-on experience. Play with Claude, play with OpenAI, play with Gemini, whatever your choice of model is or agent builder is. You know, even if you're an executive, even if you're a leader, even if you have people for that, you really need to go hands-on so you understand the nuances of the technology.
Get close to the work. I love that. Srini?
So the advice for IT leaders, right, is that go into the AI native coding. What I mean by that is agentic coding or spectrum development, whatever you call it. The reason is you don't have to get the buy-in from the rest of the company. And you are under a lot of pressure to deliver a lot. And this is an expensive technology, this is a scary technology, but this one application of taking a spec and making it code essentially solves the problem that you talked about. You talked about is probabilism now becomes determinism. The code that you have is completely deterministic code. You can test, you can deploy. You don't have to have a human in the loop for deploying this code. If you're doing agentic stuff, then you have to have a human in the loop, you have to do eval loops, all that. Use this and test like crazy before you deploy. And it's going to be cheaper, faster, secure. So that's my advice.
I love it. So, I mean, what I just heard is think about guardrails, think about systems, think about controls from day one. Make sure that we keep human beings in the conversation. But again, we augment, we don't replace. Get close to the work. And it's funny, this is something that our boss tells us a lot, is in times of change and in times of organizational and process change, understand the day-to-day aspects of it. So I love that. And then again, be willing to experiment. I think it's like find those areas where you can learn and again, get our hands dirty on it, because it's a really exciting time. And again, I think we're really entering a time when we all can be creators. And I think that's a really exciting aspect of this. So with that, I want to thank our audience. I want to thank anyone who's listened to this podcast. And I absolutely want to thank my Rockstar panel. Thank you all for being here.